Alright, logic fans, welcome back to our second video on section 6.6 quantifier negation. So for this part of the lesson, what I would like to do is I'd like you to, here's your rule, and I'd like you to determine whether each of these applications here of Qn is legitimate or illegitimate, permissible or impermissible. So this guy starts with a premise here, and then he gets from that directly to this using quantifier negation and nothing else, and the question is whether or not that is a legitimate use of quantifier negation, and likewise for A through K for all of them. Okay, so pause now, give this a shot, we'll come back together and go through them to make sure we're on the same page regarding the intricacies of the rule of replacement quantifier negation. Pause now. Alright, hopefully you've had a chance to work this through on your own, but yeah, let's just go through these. So A and B as well are both impermissible. You cannot do it. Now, it's true that sentence 1 is logically equivalent, in fact, to the conclusion. Similarly, this sentence is logically equivalent to this one, and generally speaking, you can get from this sentence to this sentence, but it requires two steps. It requires a double negation step first, as we saw at the end of the last video. And so as an implementation of the rule Qn from this to this that is not allowed, look, there's no negations in this, and the rule clearly specifies that you need a negation, okay, one way or another. So you have to add the negations using double negation. And the same story holds for B. Looking at C, that is a legitimate use of quantifier negation. That is okay, permissible, good to go. Let's look at D. That is another legitimate use of quantifier negation, good to go. Looking at E, let's see here. That is a legitimate use. It went from the inside to the outside, okay, and created stayed in terms of the variable y, went from the existential to the universal, and then you could double negate it to clean it up to just for all y fy, but that's a separate step. Okay, we're just looking at the Qn step here. Let's go ahead and look at the same thing, but instead of going from the inside to the outside, the person goes from the outside to the inside with the negation, and that is absolutely legitimate, permissible, good to go. Can you go from this to this? And the answer is no. That is wrong. Something happened to one of the negations. So if he was taking this guy from the inside to the outside, there should be two negations out here. Let's go ahead and look at H. That looks like it is impermissible. Do not do it. Not good. He went from the outside to the inside, in which case there should be two negations in here. Okay, looking at I. This is impermissible, wrong, don't do it. I hope you could spot the problem. The problem is that this has to be like this, okay? Otherwise, it's perfectly legitimate. That's fine. This is not fine, okay? The negation has to get applied not just to the fy, but to everything that goes on the inside, which is all of this, hence the need for the parentheses, okay? So as is like this, that is impermissible. Do not do it. Let's take a look at J. J is correct. So contrasting I with J is absolutely 100% illustrates that point, okay? So just make sure you're applying it correctly. J is permissible, I is impermissible. Don't do it. I bad, J good, okay? Let's look at K. So we've got this situation here, and that is permissible, that is A-okay, and the reason you're able to go inside of this conjunction and start screwing around with one of the conjuncts is that Qn is a rule of replacement and not merely a rule of inference, and so it has the power to do that. So K is permissible. All right, let's look at a couple of other examples. Okay, let's look at a few more sophisticated cases here. Go ahead and give each of these three a try, and we'll come back and look at them together. So pause now. What you're supposed to do is just sort of apply Qn to them just once. Okay, so in each of these cases, right, what's going on is you have multiple quantifiers, right? So that's what makes these ones a little bit harder. But the solution to A star here is, look, just think of it as this guy right here, right? So in A, this whole sentence is a universally quantified sentence. This is the main quantifier of it, so to speak, all right? But Qn is a rule of replacement, so we can go inside this thing and just apply it right inside of here, all right? Which means this guy goes to the outside, this switches in terms of y, and it leaves you with that. Similarly here, right? Now in this one, technically we could go one of two directions, right? We could go take this one and put it out here, or we could take this one and put it in here. In this case, what I've done is I've gone from here to inside, so this becomes a y, and it goes inside and it ranges over the whole thing. All right, and again, it's just emphasizing that Qn is a rule of replacement and not a rule of inference, so it has this power to sort of go inside this existentially quantified sentence and pull that off. Looking at C, right, we just go from here to inside, and that's exactly what we do. This stays in terms of x, and it just looks exactly like that, okay? And you could even apply it again, turning this into an all y, and then putting it in here around this whole thing. Okay, let's look at another. Okay, let's try to combine Qn with some other rules in a syntactic deduction. So in this problem, you're given a premise, which I've got for you here, and you're supposed to deduce syntactically the conclusion from that. So why don't you go ahead, give that a try, and we'll come back and do it together. Pause now. Okay, so the real key to this one, and this is a very common use of Qn, or sort of setup move to use Qn, is that this here cannot be used for Qn to move to the outside, right? It has to range over the whole thing, like this, for example, right? So there's no Qn that's actually possible here right now. But one thing you can do is, recognizing De Morgan's here, is you can pull these out to yield this via De Morgan's, and now you've got a really nice negation here that is set up for Qn, and that is a very common sort of setup move. So look for things like that when you're trying to switch quantifiers, as in this case you are. And so now that we've got this set up, we're going to move it to the outside. We're going to switch this to in terms of y. And then what we're going to do is we're going to move this one to the outside, switching quantifiers and keeping it in terms of x, right? And that's it for that one. Sorry, there ended up being an extra line here. That shouldn't be there. That's just like that. Okay, it's completely finished. And that's what you were supposed to get there. So, you know, that's a really interesting kind of thing, and sometimes there's clever uses of De Morgan's and double negation to get the negation just where you want it to be to pull off the Qn trick, and this is a good sort of introductory example into that kind of problem solving. So picking up on that thread, let's try one that involves a little more sophistication to use this sort of De Morgan style trick to set up a nice Qn. So here you're supposed to go from the universal to the existential using Qn, but there's some setup moves that are required. So we'll do this together in a second, but pause now, give it a think, and see if you can't crack it. Okay, so in this particular case, right, what we first had to do was we had to apply a double negation. In the last case, we had this sort of convenient extra negation here, which allowed an immediate use of De Morgan's. In this case, we don't have that, so we've got to sort of set things up a different way. In this case, we just use double negation on this whole thing on the inside here. And remember, double negation is a rule of replacement, so we're allowed to go inside this universally quantified sentence and do that. And then once we have it there, right, this whole thing is going to get preserved, and this negation is going to come to the outside, and we're going to switch the quantifier in terms of x, and bang, there it is. Okay, here's one that I really like. It's a lot of fun, right? It starts off with this negation of an existentially quantified sentence and concludes without referencing any particular thing that A is in fact F. So see if you can't go ahead and syntactically deduce this one. Pause now. Okay, there were two different ways to do it. You could either take this one and move it out, or you could take this one and move it in. I've chosen the latter, taking this outside one and moving it in, but you switch the quantifier, put it inside, double negate, and notice what you end up with here is a universally quantified sentence. This is something you should really look out for with your QN maneuvers. And from a universally quantified sentence, you can, of course, instantiate to the particular as discussed with UI. Okay, here's another nice problem that highlights some fun features and interesting applications of QN. Go ahead and see if you can't syntactically deduce this in terms of Z from these guys. All right, so it's important that it's in terms of Z. Pause now. Okay, hopefully you're able to give it a shot here, but one of the things that's interesting is that you've got this, there exists a y such gy, so this is a conditional, right? And this they have something in common here, gy, and so what's different is that the one is in terms of a universal quantifier and the other is in terms of an existential quantifier. So since Qn is a rule of replacement, you could either go in here and change this one, or you could go in here and change this one. It turns out that it's easiest to change this one because you already have the negation present, so there's no extra work necessary. So we move the negation to the outside and we get that, and now we've got the negation of the consequent of this conditional, which sets up modus tollens really nicely, and then you're left with this construct, and you're trying to get to this construct. So, you apply Qn to get the double negation out, and then all you have to do is, once you got Ex, Fx, is you have to realize, oh, this is in terms of Z, and so I need to go ahead and apply existential instantiation followed by existential generalization to make sure that it's in the terms of the variable that the problem specifies. So that's kind of an interesting problem, but these kinds of sets up, can I set up a modus ponens, a modus tollens, a disjunctive syllogism of some kind? Be sure you're looking at the practice problems in the text to really hone your problem-solving skills with these. All right, logic fans, that's it for this one, and we'll see you on the next video.